So we continue our journey. We're going to start reviewing some Chapter 5 stuff here. This is number 11 off of the test that is labeled. It doesn't have a label, but it actually runs from 3.1 through 5.3. That was the third test that you would have taken during this semester. And this is a problem where we're dealing with exponents. And when we were covering this stuff, we encouraged you to do these outside exponents first, and we handle those by multiplying the exponents. So, on this problem, we keep r cubed. 4 times 3 would give me r to the 12th over 2 times negative 5 will give me r to the negative 10. Okay, so the outside exponents first. Do you remember what I encouraged you to do next?
Negatives on top.
All the negatives, that's right. So we only have one r with a negative exponent here. It's this negative r to the negative 10. So remember, to make an exponent positive, you change the level. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. So in this case, we're going to the numerator. So I have r cubed, r to the 12th, and now r to the 10th. And then after you do those two things, we're going to finish by either multiplying or canceling. In this case, it's multiplying. And when we multiply, we add the exponents. 3 and 12 is 15, and 10 is 25. So you end up with r to the 25th power here. So you're likely to see a problem somewhere on your final dealing with exponents. Okay, that gets us into the chapter, well, let me rephrase that. That gets us into all the polynomials problems that we did in chapter 5. Number 12 off of that test had 8n to the 7th. I know that's a little hard to see. Give me just a second here. Plus 7n minus 8n to the 4th. And we're adding to that 2n to the 4th plus 2n to the 7th. I have to darken that down a little bit. There. And plus 6n. So it's an add problem. It is not a multiply problem. So the most common mistake that's made on the test is students start multiplying whenever they should be adding. If it's an add problem, we're just combining like terms. That's all. So 8n to the 7th and 2n to the 7th is 10n to the 7th. Done with the n to the 7th. Negative 8n to the 4th plus 2n to the 4th is negative 6n to the 4th. Done with the n to the 4ths. 7n plus 6n is 13n. I've got a question for you. If this would have been minus, what's the only thing that I would have done differently? Distribute the negative first, and then you'd combine the like terms. That's right. Okay, the next problem that I have picked out to do is number 14. It's a problem that has a function. F of x is equal to 8x squared minus 9x plus 10. And we're asked to find f of 2. Do you remember how we found f of 2? Excellent. That's exactly what you do. F of 2 is going to equal 8 times 2 squared minus 9 times 2 plus 10. Now we got to follow the order of operations, so we got to do exponents before we multiply. So 2 squared is 4, so we got 8 times 4 minus 9 times 2 plus 10. Got to multiply before we add. 8 times 4 is 32, minus 9 times 2 is minus 18. And if you add and subtract from left to right, you're going to end up with 24. So a little problem there on function notation, and that is a wrap off of that test. Yes, ma'am.
You don't do anything with the plus 2
What plus 2?
equal, oh, F2.
The f of 2 is telling you to put the 2 in where these x's are. That's what f of 2 means to do.
Okay, so that's all that means you.
Yep.
Okay.
That's it. Okay. Moving this show on down the road here. I don't think this is going to show up, but I'm going to try it anyway. The next test that we're pulling problems off of said test chapters 5, 6, and 9 at the very top. The first problem on it had negative 2r to the fourth plus 9r cubed minus 3r minus blah, 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 blah. This was the test where you had all the factoring. Okay, but we've still got a little bit of chapter 5 stuff even on this test. So let's take a look at the rest of that first. That didn't work very good, did it? Number 5 has 2x squared plus 4x plus 2. And I'm going to multiply that by x squared minus 3x plus 4. So this is a multiply problem, so here we are going to distribute. So let's take the 2x squared through. 2x squared times x squared is 2x to the fourth. 2x squared times negative 3x is negative 6x cubed. 2x squared times 4 is 8x squared. Done with the 2x squared. Let's take the 4x through. 4x times x squared is 4x cubed. 4x times negative 3x is negative 12x squared. 4x times 4 is 16x. Done with the 4x. Let's take the 2 through. 2 times x squared is 2x squared. 2 times negative 3x is negative 6x. 2 times 4 is 8. Done with the 2. Done distributing. Now we'll combine like terms. So I've got this 2x to the fourth, and that's the only x to the fourth term I have. I've got negative 6x cubed and plus 4x cubed, so that'll give me negative 2x cubed. Done with those. I've got 8x squared minus 12x squared to be minus 4x squared, but then I got this plus 2x squared down here as well. So minus 4 and plus 2 will give me negative 2x squared. Done with those. It's 16x and minus 6x is 10x. Done with those. And my only constant is 8. By the way, this is also excellent review if it's the chapter 5, 6, and 9 test that you're going to be retaking. So this will help get you ready for that as well. Everybody good there? Okay, moving on to number 6. Off of that test, which was a division problem. It had x squared plus 2x minus 15 over x plus 5. Now, let's stop for a minute. Some of you might be saying, hey, didn't we do problems like this in chapter 7? We just simplified them. And the answer was maybe yes, maybe no. It depends on this particular problem. If we can get the numerator to factor, and then we can cancel, then yes, we can do the problem like we did it in chapter 7. If we look here, the numerator would factor quite easily because 2 factors in negative 15 that add up to 2 would be plus 5 and minus 3. So then the plus 5s would cancel, and we just get x minus 3. So yes, on this particular problem, we could do it like we did in chapter 7. But you can't do all problems that are like this in that fashion because some problems, the numerator won't factor. And even if it does, you may not get anything to cancel. So when we were doing these problems in chapter 5, we were doing long division, and that's what my intention was for you to use on this problem. Set it up in this fashion. Okay, so here's the way we thought back when we were doing these problems. The first thing we said was, let's find our first multiplier. And we do that by taking the first term in here over the first term out here. X squared over x would give me x. So that's my first multiplier, x. Now we're going to distribute. X times x is x squared. X times 5 is 5x. When you draw the line, change the signs. Okay, those cancel. 2x minus 5x is negative 3x. And we're going to bring down the minus 15. And all we're going to do is repeat that process again. Again, take the first, the negative 3x, over the first on the outside is the x. So negative 3x over x would give me negative 3 because those x's would cancel. So that's my next multiplier. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Draw the line and change the signs. On this problem we get no remainder, so that's nice. If we would have got a remainder, then you couldn't have done this problem the chapter 7 way. That's another way that you know that you can't do it that way. So a little long division. Ryan, how many of those you want on the test? You don't like those? Okay, that means we're going to roll into chapter 6. Chapter 6 was largely about factoring. And we've said it about 600 times by now. Look for a common factor first, then count the number of terms. If it's got 4, we do grouping. If it's got 3, we'll do the AC method. We might be able to use the shortcut if there's a 1 on the squared term. If there's 2, we're going to check difference of squares first. And if it's not that, then we'll check to see if it's the sum or the difference of cubes.
I have a question.
Yes, ma'am.
On the last problem, where it's negative 3x minus 15, and then you distribute the 3, do you, I guess you draw another line and change the negative?
Okay. Whenever we had the negative 3 up here, we multiplied by it. Negative 3 times x made negative 3x. Negative 3 times 5 made negative 15. Okay, now we're going to subtract that amount. To do that, that's equivalent to changing both of the signs. That's why we say when we draw the line, both of these signs then change, and that's how I ended up with 3x plus 15. And now if you combine the like terms, negative 15 and 15 cancel. Negative 3x and 3x cancel. So we got no remainder on that problem.
Alright, I just didn't see the line, so I was like, how did the negative and negative 3x negative 3x cancel?
It's there.
Okay, thank you.
Okie dokie, class. So here comes a bunch of factoring problems. Now listen, for some of you, I'm not saying all of you, for some of you, this is the root of why you had trouble with chapter 7. Because you had trouble with chapter 6. So we got to get the factoring stuff. You get the factoring stuff, that goes a long way to helping with chapter 7. So, number 7 off of the test, and I've chosen several of these because it's such a big part of the class, is 4x cubed plus 20x. So if we look for a common factor there, in 4 and 20, we can take out a 4 out of both of those. And remember, the variable can come out to its lowest power. So I got a cube, and I got a first over here, so we can take a 4x to the first out. Four x cubed divided by 4x will leave x squared. 20x divided by 4x would leave 5. So you have 4x times the quantity x squared plus 5. That's not too bad, is it? Okay. Here's number 8. Number 8 had x cubed plus 3x squared minus 5x minus 15. Class, what method should we use to factor this problem? Grouping. But first we should check to see if there's a common factor. And on this problem there is not one. So let's do grouping. Group the first two. Don't forget the minus has to go with the 5. So we'll slip a little plus in there to show that they're still being added. How about out of x cubed and 3x squared? Well, we could take an x squared out. X squared out of x cubed leaves x. X squared out of 3x squared leaves 3. Now listen, here comes the question. What do we factor out of the last two? And the answer is we factor out whatever would leave us an x plus 3 inside the parentheses. If there is anything that would do that. Okay, and in this case there is. Now class, a lot of people would say 5. If I factor a positive 5 out, do you see that's going to leave a negative x and a negative 3? I'm going to have to factor a negative 5 out to end up with a positive x and a positive 3 inside the parentheses. Negative 5x divided by negative 5 is positive x. Negative 15 divided by negative 5 is positive 3. Okay, so we have one factor of x plus 3 and another factor of x squared minus 5. Well, the next problem I picked out was number 9. It had x squared minus x minus 72. Let's look for a common factor. We don't find one. We count the terms. It's got 3. We'll do the AC method, but here we can use the shortcut because there's a 1 on the squared term. If there's not a 1 on the squared term, then there's no shortcut. But here there is, so we're golden. So 1 times negative 72 is negative 72. Okay, now I want everybody to stop for a second. Some of you have really good, what mathematicians call number sense. Okay, and I'm not talking about sense and the fact of being smart. I'm just talking about factors and multiples and those things like that come pretty naturally to you. That's good number sense. So some of you see what two factors in negative 72 add up to negative 1 like that. Some of you have trouble with that. So if you're the person that has trouble, make the list. Make the list like we talked about in class. So just start with a 1. 1 times negative 72 or negative 1 times 72. That'd equal negative 72. We need those to add up to this negative 1 that's in the middle here, and neither one of them do. So let's just work our way up. Ask yourself if 2 goes into 72. It does, 36 times. So 2 and negative 36, or negative 2 and 36. But those add up to negative 34 and 34, so that's not it. How about 3? Well, 3 goes into 72 24 times. So 3 and negative 24, or negative 3 and 24. Neither of which add up to negative 1. You try 4. 4 goes into 72 18 times, so 4 and negative 18, or negative 4 and 18. Neither one of those do it. So you try 5. 5 doesn't go into 72. You try 6. 6 goes into 72 12 times. 6 and negative 12 is negative 6. Negative 6 and 12 is positive 6. Neither one of those is negative 1. That's not it. Try 7. 7 doesn't go into 72. Try 8. 8 goes into 72 9 times. So 8 and negative 9, or negative 8 and 9. And lo and behold, 8 and negative 9 add up to negative 1. So that's the combo you need. So we end up with x plus 8 times x minus 9. So if you're having trouble, make the list. Okay? You know what? I've told you guys I'm a big Dave Ramsey fan. So I don't know if you guys are familiar with Dave Ramsey, but he gives financial advice. So people call into his show, and he's got these baby steps to follow, and they say, yeah, but my situation, I want to do this and this and that and that. And he says, well, how's that working for you? And it kind of sounds smart aleck, but if you listen, it makes sense. He'll say to them, doing what you do has got you in the situation that you're in. What point am I trying to make? If you've been having trouble and haven't been doing this, you're still having trouble. So try something different. So this is my suggestion. If you're having trouble finding those factor pairs, make the list. It will become clear to you. It feels like it's taking you extra time, but when you're sitting there racking your brain, it might actually be costing you time. So, if you want different results, you got to do something different. That's true in just about any aspect of our lives. Okay, the next problem I wanted to look at was number 10. 14x squared minus 49x minus 28. Let's look for a common factor. What do you think, class? Come on, Salvador. Come on, bring it. Let's take a 7 out of all three of those. 7 out of 14 leaves 2x squared. 7 out of 49 leaves 7x. 7 out of 28 leaves 4. Now let's try to factor what's left on the inside. It has 3 terms, so we're going to do the AC method. We cannot use the shortcut. So, what are we going to do? We're going to leave 2x squared alone. We're going to leave minus 4 alone. 2 times minus 4 is negative 8. Let's look for a factor pair of negative 8 that adds up to negative 7. Guess I'll make my list again. 1 goes into 8 8 times. Either 1 and negative 8 or negative 1 and 8. And looky there. The very first 1 and negative 8 adds up to negative 7. So how's that negative 7x going to flesh out? It's going to be plus 1x minus 8x. Hey, Mr. Black, making a little list makes sense, you know? Yeah, it does. Sure does. Let's do some grouping. So, out of 2x squared and x, we could take out an x. It's going to leave 2x and plus 1. Out of negative 8x and negative 4, think about what would I have to take out so that I can be left with a 2x plus 1. Well, do you see the signs are going to have to flop for that to happen? So I'm going to take out a negative, and out of 8 and 4, you can take out a 4. So at the end of the day, I've got a 7, a 2x plus 1, and an x minus 4.
So nothing happens with the x when 7?
This x, it's right here. See, the two that are the same, that makes one factor in your answer. So sometimes I'll say that's the stuff on the inside of the parentheses. And then the stuff on the outside, this guy and this guy, makes your other factor. Hey class, look how cool I got multiple colors going on to illustrate things. Mr. Black, that's not that cool. Okay. Well, I was trying to be cool. Usually if you try to be cool, it doesn't work. Okay. Let's keep moving on down the road. So, Number 11 is next. On number 11, we have 50x squared minus 98. I'm going to move a little quicker on this one. If I look for a common factor, those are both even numbers, so I know I can take a 2 out. 2 out of 50 leaves 25x squared. 2 out of 98 leaves 49. So we are left with something that has 2 terms in the parentheses. If it's got 2 terms, according to what we said earlier, we need to check first to see if it's the difference of squares. It is a difference because it's minus. 25x squared would be 5x times 5x, and 49 would be 7 times 7. So it is the difference of squares. So here's how we factored that. Do you remember this? We did 5x and 5x. We did 7 and 7. We put a minus in one and a plus in the other. Okay, I had the cubes problem picked out for us to work, but you know what? I'm not even going to work it. I'm going to tell you not to mess with the cubes problem on your test, okay? If you can AC method, group, and do difference of squares, we'll call that good enough for your final. If you take college algebra, you're going to see some differences of cubes again. If you take gen ed math, you probably won't. So we're going to major on the majors here. Ryan, you're awful quiet. What are you thinking? Okay. Donna, you got a thought back there? Okay. And Nikita, I wasn't expecting to see you today, so this is a pleasant surprise.
Yes, I'm very happy.
And I see that Adam is in, I see his elbow. There he is. Okay. Alrighty then. Moving on down the road. Let's look at number 13. Which has 2k squared equal to 24k minus 64. Class, the first thing I want you to notice is that this problem is different. It's different for 2 reasons. Number 1, it's got an equal sign, which makes it an equation. And the directions for an equation are always solve. It's the only thing we've done with equations in this class other than graph them. So, on this problem I said to solve by factoring. Okay, well, we've been saying over and over again, is the equation quadratic or is it linear? This one's quadratic because we got the power of 2. If it's quadratic, we always set it equal to 0. So let's subtract 24k from both sides. Let's add 64 to both sides. So on the left side, I have 2k squared minus 24k plus 64. And on the right side, it all cancels and I got a 0. Okay, now let's look for a common factor. Out of 2 and 24 and 64, we can factor a 2 out. 2 out of 2k squared leaves k squared. 2 out of 24k leaves 12k. 2 out of 64 leaves 32. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, now let's think about what's left inside now. It's got 3 terms. So I'm going to do the AC method. I can use the shortcut because I got a 1 on the squared term. So listen, we've done it a couple times now, so you know to do this if you're having trouble. I'm not going to take any more time on the rest of these today so that we have plenty of time to get through everything. 1 times 32 is 32. 2 factors of 32 that add up to negative 12 are negative 8 and negative 4. If you go through your list, that's what you end up with. So I have 2 times k minus 8 times k minus 4 equal to 0. We'll take each factor then, set it equal to 0, and solve. If you think about it, the 2, it can't equal 0. So we're going to ignore it. So either k minus 8 is equal to 0, or k minus 4 is equal to 0. Adding 8 gives k equal to 8. Adding 4 gives k equal to 4. So you're certainly going to have some quadratic equations to solve. And you may be asked to do one by factoring. Now on that test we also had one where, actually you didn't. I thought you had one where you had to complete the square, but you don't. Don't worry about completing the square for your final.
This one on 15 is completing the square.
Oh, it's on the back, yeah. Don't worry about 15. But you will need to know the quadratic formula. And I like the problem that's on your test, number 14, where I told you to use the quadratic formula. But I want to look at something a little bit more involved because you could have something a little bit more involved on your final. And we've only practiced like one of the kind I'm going to get ready to give you. So give me just a second here and let me look up just the problem that I want. So this is the problem that I want us to do. It says this: 2x squared plus 3x minus 1 is equal to 0. So if you had this problem on your final and you said to yourself, well, here's the way you would think. First of all, you'd say, is this quadratic or linear? Well, it's quadratic. So we get a 0, and on this problem that's done. Then you'd say, okay, I'm either going to factor or use the quadratic formula. If you tried to factor it, you would be doing the AC method. 2 times negative 1 is negative 2. The only factor pairs of negative 2 are 2 and negative 1 and negative 2 and 1, neither of which add up to 3. So it won't factor. So you have to use the quadratic formula or complete the square, which I don't think you want to do that. So, all right. So first order of business is you got to know the quadratic formula, okay? And listen, when you walk into someone's college algebra class, if any of you do from here, and they say, do you know the quadratic formula? I want you to know it. Okay, that's part of what this class is designed to do. So, hopefully you know it's negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't know that, it's time to know that. Okay, so in this case the a is 2, the b is 3, and the c is negative 1. So let's plug in. So negative b will be negative 3 plus or minus the square root of b squared will be 3 squared, or 9, minus 4 times a is 2, and c is negative 1. All over 2a would be 2 times 2. Okay, and again, like I said after we did chapter 8, we want to write these with simplified radicals now instead of just decimals. So let's work on this square root over here. Negative 4 times 2 is negative 8, times negative 1 is positive 8. 9 and 8 is 17, so I got the square root of 17 there now. Now if I could simplify that root 17, or some of you say break down, if I could break that down I would, but it doesn't break down. So here's my answer, negative 3 plus or minus the square root of 17 all over 2 times 2 is 4. Now how many answers are sitting here? We have 2. So you might see the answer written this way. Negative 3 plus the square root of 17 over 4. And negative 3 minus the square root of 17 over 4. So if you see that, don't be fooled by it. This is the same thing as that. Okay, that's kind of what we had shaken for chapters 5, 6, and 9 as far as the review is concerned.